All right. I get to do this next slide. This is my favorite slide. Everyone take a picture of this one. If you've seen this before, raise your hand. I can't really see past like the third row. There's these bright lights back here. We'll get to that here in a second. This is the forward-looking statement slide. There are two things you need to remember about this. One, I'm not supposed to make forward-looking statements. Two, you're not supposed to make purchasing decisions except on things that are publicly accessible, publicly available, and GA. Does that make sense? All right, great. So, I am Kevin Poorman. I am a developer evangelist here at Salesforce. I like to run a little contest. I've got some swag up here. If you take a picture of me in a funny pose, and you tweet about it, hit me up on @CodeFryer. I will give you a piece of fun swag. I like to try and make my sessions fun. Testing can have this sad idea that it's, but testing is a lot of fun, and we're going to have a lot of fun in our session here today. So let's keep it fun and light. So what are we going to talk about today? We're going to talk about advanced Apex testing, of course. But what does that mean? We're going to talk specifically about test visible and test setup annotations. We're going to talk about using CSVs for fun and profit. And we're going to talk about asserting our sanity. And I'm not talking about saying I am mentally sane. We're talking about data sanity. We're going to talk about using mocks and where and how to use them. We're going to stub things other than our toes for great good. We're going to talk about whether or not DML is evil. Hint, I think it sometimes is. Okay, it's evil. Okay, and at the end we'll have some Q&A time. Now some people might think of this as a tips and tricks type thing. I'm going to walk through this as if it were code recipes, things that you can do in your own tests to try and make them better, faster, stronger, more like Iron Man. If you need a new part, slap one on, refactor this thing in. Less, this is best practice. Isn't this pretty? Okay, all with me? Now, I told you about the bright lights in the back. I can't really see anything past the third or fourth row. If you have a question, jump up, run to the front. There's a mic here. It's for stand-up comedy. No. Jump up, run up, and ask your question. I can't see if you raise your hand, but I really do want to answer your questions. So help me out. If you have a question, hit up the mic, or just start yelling, because I can hear. All right? Can we make that deal? Great. So, I want to start off with, what do we want in our unit tests? We want fast unit tests. Why do we want fast unit tests? Anybody want to throw out an idea? We want fast unit tests so we know when things break faster, so as we're refactoring things, we can know, oh, that refactor was not a good idea. Let's undo that part. We want to be able to have that feedback loop quickly. We want tests that are easily understood. What does this mean? We want tests that aren't 7 miles long in our class. We want tests that are going to fit on a page, that are easy to understand. We're going to grab this data. We're going to walk through this thing. This is what we expect. Here's how we're testing it. Good to go. Easy to understand. The new guy or new gal on your team should be able, on day one, be able to read through your tests and go, okay, I don't know necessarily what this code does or what necessarily the business logic is, but I know this test is calling it, it's sending this data in, and it's expecting this result. Nice and simple. We want tests that are repeatable. Why do we want them to be repeatable? By the way, I do interactive sessions, so you have to talk to me as well. I'm going to keep asking questions. We can have awkward silences. It's kind of like my dating life. So why do we want repeatable tests? So you know things are working so that you know your tests aren't brittle. You don't want to have Cinderella tests. I call these Cinderella tests. They're tests that pass until midnight when they turn back into pumpkins. Yeah. We want descriptive unit tests. We want unit tests that when they fail, they tell you why they failed. Who wants to get a report from a user in the morning or from your release manager saying, hey, this unit test is failing, and it says, assertion failed. Meh. Now, I used to be a contractor, and I worked for, at one point in time, I have written code and worked with code in 5 of the 10 largest Salesforce orgs. So I've seen a lot of unit tests, and I've seen a lot of really crazy unit tests, and I've seen a lot of really good ones, and I've seen a lot of assertions that have no comments in them. Just, oh, you'll get assertion failed. This drives me crazy. I don't want to be judgmental, but if you're not leaving yourself a note about why the assertion failed when it fails, you're doing yourself a disservice, because the first thing you got to do is go look up which assertion it was. So we're going to talk about why we want descriptive unit tests, and we're going to show and talk about why we want definitive unit tests. We want tests that fail for one reason only. If you have a test that can fail for more than one reason, what should you do? Put it into 2 tests. That's right. So let's talk about test visible and test setup. These are annotations. I like annotations. Some people really hate them. You can put them on the same line as your method or member variable. You can put them on the line above your member variable or method definition. It doesn't matter. That's a stylistic fight you can have with your team. In this case, they're on there so I can fit everything on the screen. When you have a test visible member variable, that private variable is suddenly available and acts as if it were public, but only during a test context. Does that make sense? How many times have you been writing a unit test and you have a private member variable and you want to keep it private, but you don't have any code coverage on that private variable because it's private? Does this ever happen to anybody? Now, oftentimes this gets glossed over because you're using it somewhere else in a method and you're hitting that method and it's getting used there. But sometimes you'll have just this one dangling line and you're like, I have 99.3. Why can't I have this one line? Test visible. Super simple.
Everything is by default test visible or
I'm sorry, say that again?
why not everything is test visible by default?
That's a great question. And I don't know that I have a great answer for you. Tell you what, if you tweet me, I will go ring the developers of the Apex language and ask them. I suspect what they're going to say is we didn't think of it to start with, and then we sort of retrofitted test visible in. Test visible isn't necessarily new, but it is new-ish. I think it came in API version 30, so we're on 43, so about 5 years ago is my guess. So it's new-ish. That's your answer to that's an answer.
You write your test class, your test methods in the same class.
That's true.
And then private didn't matter.
Yeah, that's true. You could write them in there, and then they broke that with like 27, and then and you can also do test visible with methods. I like to have very small methods in my classes. I like to have methods that are simple to test. They do one thing, they play nicely with others. I like to compose things. And so I like to have very short methods. They're often very private because they're only used in this class. I like to use test visible in order to have unit tests, make very simple unit tests for my classes. Test visible makes testing much, much simpler. Has anybody used test visible before? Okay, you may be like, this isn't exactly advanced, Kevin. Is anybody feeling this way? That's totally fair. That's totally fair. I also run into people who are like, what does test visible do? So we're hitting all the doorstops today. So when you run a test you want to run a test with test visible, you just write it as if it were public. No big deal here. You're just going to access it as if it were public. Since a lot of people seem to have used that, I'm going to skip right past it. So let's talk about using CSVs for fun and profit. How many people use CSVs to load data for their unit tests? Much fewer people. All right, how many people just found out about this? This is my favorite way of loading data for unit tests. You can, sooner or later, when you write your unit test, you've got to put data in place for those tests. Test data makes tests matter. Without test data, your tests are dubious at best. So you can either brute force it, you can create an account and insert it, or you can start loading those data from CSV files. Now, when you load it from a CSV file, you're going to upload that CSV file as a static resource, and all you're doing is creating a CSV with the field names on the top row and the data on the following rows. So you see here we've got an account CSV, name, website, phone, etc. And we've got 3 rows of actual data. And we're going to store this in our org as a static resource named account data. And then what we're going to do is in our test, we're going to use a test setup method. That test setup method, we're putting it in a test setup method for a very specific reason. And that very specific reason is this. If we fail to hydrate that CSV into a list of accounts and insert those into the database using this load data method, that test setup method will fail. An exception will be thrown. And if that exception is thrown in a test setup method, what happens? None of my tests run, they all fail. Which means that we know if our data fails to be inserted, all of our tests will fail. We want that to happen. If our data doesn't show up, we don't even want to try to run our tests, right? So how this works, we're going to tell it what kind of object it is. Let's see if my technology is working here. Yeah, here we go. So we're going to say account.sObject. This can be any sObject in your org. And you're going to give it a static resource name. So in our case, we could say account data, and it's an account sObject. Now notice what we're not doing. We're not telling it to insert. It's going to take care of that for us. That's handy, isn't it? And we are doing it in the test setup. I'm really driving that test setup home. Pretty simple. Now, I taught a class, a hands-on workshop yesterday and the day before yesterday, and the number one question I got was, well, how do I do groups of related objects with CSVs? And that's a great question, and it's easy enough to do. The hardest part about doing it is to maintain the insert order in your code. So if you look here, we're going to do accounts, then contacts, then opportunities. Now, if you think about this, if we tried to insert opportunities before we had accounts, that obviously wouldn't work. We would have no account IDs, etc. But then they were like, well, how do you make that work? What is the relational IDs on the accounts and contacts? Here's how this works. When you create your CSV, you can create an ID field, and you can give it a number. That number can be anything you want. It does not have to be sequential. It does have to be relationally sane, right? So on the top, we have accounts. On the bottom, we have contacts. And my account ID is the second column there. I've highlighted it. And I'm sending the account ID from the top row. Now, I can continue down the chain with this. So if I switch over to opportunities, so on top is my contacts, below is my opportunities, you'll see that I've got an account ID and a contact ID, and I've mapped that as well. Now, when I go back to my code 2 slides ago, when I insert those, it's going to insert the accounts, and then knowing that it's got account IDs, it's going to insert the contacts to match those account IDs, and then finally insert the opportunities matching and referencing those account and contact IDs. I think I see a hand back there, but
Could you leave the Salesforce IDs in the CSV and will it translate them on insert?
No. No. And this relies on a feature that came about, I want to say, in API 37. Don't quote me on that part. Where, as of that API version, you can create an object, and in memory, you can specify its ID. Okay? Until you try to insert it. But as soon as you try to insert it, if there's an ID there, it will fail. And we'll get to that more here in a little bit. We're going to use that here in a little bit. But this is using that feature as well. You cannot store an actual ID and then try to insert that ID. That will fail because it's going to be a reused ID. All right? So you can insert complex trees. The hardest part you have to do is to create the CSVs and insert them in order. Does that make sense? I can't see you, so I need to yay! All right, good. All right. That might be the most complex one. Here's why I really like using CSVs for test data. If you write your tests to execute the same test logic in bulk, every time you add a row to your CSV, you're effectively adding yet another edge case to your test data. Now, if you've ever gotten a report, hey, we need to add, we just discovered that if you send somebody whose name ends in has an apostrophe in it to the integration breaks. So we just wrote a code patch, but we need to add some tests to our code base so that when we send Grace O'Malley through the integration, it doesn't break. Well, if you go into your code base and you have to manually add Grace O'Malley as a contact, if you're hard coding that contact creation in your tests, you're going to end up with just more stuff in your test class. But if you're adding this to a CSV and you're setting it up so you're going to run, Tom Daniels and then Nate Ford and then Betty Ford and then Grace O'Malley, and you're doing it, one account at a time, what you're doing is you're running the same unit test logic, but with different data sets. Does that make sense? This becomes really powerful. And not only that, you don't have to be the one to maintain the test data, but that's a double-edged sword. Anybody with system administrator privileges can go in and upload a new static resource under that same name, which means that you don't have to be the one who's maintaining the CSV, but it also means that anybody can go in and upload a blank CSV and break all your tests. Okay? So it's important that you version control your CSVs. All right. Let's talk about asserting our sanity. Turns out I don't mean sitting in a meeting and yelling, "I'm sane," because few people will believe you.
Real quick, for the test setup, is that a transactional? Does it basically commit all of that data, and then when you run tests, does it roll back to the database to the state of all that data? Or does it have to reinsert that data for every test? Now, do you get a speed benefit by doing all of this insertion in your test setup instead of having stuff in each test?
The test setup method will run before every test method, and at the end of every test method, the database is rolled back.
Okay, so it does actually reinsert all the objects before every test. It's
Yes.
not like inserting once, marking, doing test, roll back, do test, roll back. It reinserts every time.
That's my understanding. Now, they could have an optimization in there that I know it's reset to how it's reset. I'm not entirely clear on.
I think it's actually managed with two save points. So they do test setup, mark a save point, run a test method, roll back the save point, run a different test method, roll back the save point, and eventually they roll back to before test setup.
I was going to say they might do it that way, but it's reset up.
Okay, that would be the question, because test setup in that case should be faster, especially if you're inserting a lot of data.
Yes, it is.
Yeah, it is definitely faster to use that. I'm not clear what the mechanism they're using underneath the covers is. So when I talk about sanity assertions, I'm talking about assertions that are made in your tests before you call test.startTest. We're all using test.startTest, right? Yes, that was a little weak. Let's try that again. We're all using test.startTest, right? There is a correct answer to this. Yes. Okay, good. Now, anything after test.startTest is fair game for an assertion of the results of your tested code. I'm fine with that. That's how you're testing the results of your code. However, anything beforehand, I'm going to call a sanity check. What do I mean by that? I'm saying that you should make sanity checks before you call your tested code, the code you're testing, to make sure that your data is what you need it to be before you actually test the code. Why?
Because if it ends up that way, it's already the way it started, your code didn't do it.
Exactly. That way you know at 4 in the morning when you get the emergency call that your code is broken because the code is broken and not because the test is broken. Not because somebody uploaded a bad CSV, but because something changed in a method somewhere and now it is not acting the way it should. Half the battle of knowing and debugging a unit test is knowing what you don't have to figure out, right? So if you know going into this, I got to figure out why this unit test is failing, that your data is asserted to be correct before you run any code, you're already off to the races. This has saved me so much time over the years. And you'll notice here that I put data failure at the beginning of all my sanity checks. You don't have to do that, but it's nice to yourself. Okay? Does this make sense? This is a super simple one, and I often have several sanity checks. I may be checking for opportunities. And I don't necessarily do these for things that I've hydrated from CSVs because I trust the test setup method is going to fail to hydrate and die if something's wrong in my CSVs. But if for anything I'm manually creating or anything that I'm mutating, so if I load a bunch of opportunities and then I change the amounts because I need to for the way I'm testing my code, I'll check that my updates worked. Does that make sense?
Would you put a sanity check in your test set?
No.
Why not?
It depends, but often my test setup is generic enough to give me data that I'm then going to have to change in some way for specific tests.
Okay.
that make sense? His question was great. Would I put a sanity check in the test setup? I said no, because oftentimes my test setup is giving me generic enough data that I'm mutating it in some way in the individual tests because of what I'm actually testing in those tests. Does that make sense? Great. So let's talk about mocking things. It's not just for politicians anymore. When I say mocking all the things, I don't mean everything literally. We'll get to that in a bit, but I do mean HTTP callouts. How many people are using test is running test to determine to get around the not being able to call a callout in a test environment? Yeah, I don't want to be judgmental, but there's a better way to do that, and this is the way to do it. You can use a HTTP callout mock. And to do that, you create a mock class, and you can insert this mock and insert it into your test and set it up as the mock. And when your code makes that callout, the mock will be returned instead of the callout. Does that make sense? So instead of the callout actually being made, your mock will be returned. And we'll look at how that works here in just a second. But basically what happens is you're going to create this new mock. I've called mine HTTP mock factory. We'll see why in just a second. And you're going to call set mock. It's in the test namespace. And when you call start test, whatever code you're calling, you're testing that makes that call out, when it makes the call out, whatever call out it makes, the system is going to say, okay, you're calling google.com. I'm not actually going to try to call google.com. Whatever your response method is in your mock is what I'm going to actually return. Okay, so let's look at that. The mock factory, and you create your own mock classes. So I called mine HTTP mock factory. It implements this class, HTTP callout mock, and there's one method you have to specify, the respond method. And it takes a parameter, the request method, and it responds with an HTTP response. So you get to craft the response however you'd like. I tend to do this by creating a factory. And when I say a factory, what I'm doing is I'm creating a constructor in my class, and I'm accepting all the parameters I need to construct an HTTP response object. So the code, the status, the body, and the headers. Okay? Which means that in my test, I can say, okay, give me a 200 response, okay, status, here's the body I want, and my headers are, blank or whatever. I can construct a mock in my test, right there in the test code, set it as the mock, and move on. But sometimes I actually need to test more than one callout. How many people have integrations where you're making several callouts in one method? My total is 17. Anybody beat 17? Insurance stuff is complicated. So 17 callouts. The way you handle that is this: you can only set the mock once in your test. Once you've started a unit test, you can only call set mock once. However, you can construct the mock this way to respond with a list, to respond with the first object in the list of HTTP response objects. So you can create in your test a list of 17 mock responses and have it just return the first one. Does that make sense? How many people think this will save them time? Here's where this gets really important. You probably know all about positive testing and negative testing. Have you tried to do positive and negative testing with your callouts? And what I mean by that is you probably test positively. My callout goes out and it returns a 200, okay, here's my data. But have you tried saying, okay, my callout doesn't respond at all? Or my callout responds with a 404, or a 302, or a 500 server error? Using a callout like this, you can have you can construct a error message on the fly in your test and say, I'm going to negatively test what happens when I get a 500 and how my code responds. Should it retry? Okay, great, it should retry, and then I'm going to give it a 200. Okay, great, it failed, and then it retried, and it passed. Good, I know that I have resilient code. It should retry 3 times. I mean, boom, 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 good, it worked then. So on and so forth. Does that make sense? How would I do a timeout on that?
Would you just send back a not object, or what would that
hit me up afterwards. I don't want to, we're running short on time. So, okay. System.stubProvider. Now, when I say mock all the things, mock is sort of, I use it as a generic term. A stub is a type of mock. A mock is a very specific term that means a object that is going to return your predefined value. A stub is a sort of mock factory that is going to give you a way of returning your predefined value as you construct it. So the way you can use a stub is, and the way you're going to use a stub is to think about it as conditionally injecting a mock that you create on the fly of a method call. So you're going to take a method call, you're going to say, I have this method call, it's great, I just don't want to worry about it in my unit test, I'm going to stub it, I'm going to mock it out, and I'm going to turn around and provide a mock instance. And you can do this on pretty much any method call. I say pretty much any method call, you'll see that some exclusions apply. Some caveats apply. You can't do static methods. You can't do properties. So you can't do getters or setters. You can't do inner classes or system types. System types is like integers, that sort of thing. And you can't do triggers or batchable classes. And I realize that's a whole lot of caveats, but that's still a small subset of the things in your org, right? So the idea here is we're going to implement this in a class. We're going to implement the stub provider interface, just like we did with the mock provider interface. And you're going to create this in a way that'll handle multiple method calls. So if we look at this, and I'm sorry this is a little bit smaller, it's a lot of code here, but we have a example stub mock class, and it's going to implement the stub provider system.stubProvider interface. And we've got this one method call that we have to implement, the handle method call, and it's going to accept a whole bunch of information here. And this information is for your benefit. The stubbed object, the stubbed method name, the return type, the list of parameter types, the list of parameter names, and the list of args. These are for your benefit, and I say that because you can use these to tailor your crafted response, tailor your mocked response based on the information coming in. So in this case, if you look here, we're using the switch statement, and we're going to switch on the stubbed method name. So depending on what method we're calling, when this stub is invoked by the system, we're going to return different things. So if we call awesome method 1 on our stubbed object, we're going to return yay called another awesome method 1. If we call add two numbers, we're going to return 4. Now notice these aren't the same types. One's a string, one's an integer. And we also have this one down here. It says, we're going to say when we call polytype method name, we're also going to look not just at the name of the method, but at the type it returns. Because if the return type is Boolean, we'll return true. If the return type is account, we'll return an account. Now that's sort of very sort of conjured up example, but that'll give you an idea of what you can do with the stub. Now, these are a little complicated to use, so I'm going to give you an example that's very stripped down here. What we're going to do is we're going to have a date formatter class, and it's going to accept in our one method in this class a date helper class. This is the code that we're going to test, and we've got a date helper object that has a get today's date, and this is the date helper object that we're going to stub, and we're going to use this stub to get a mock of the get today's date method. Did everyone follow that? That was the complicated bit. That was the most complicated sentence in this entire presentation. All right, so here's how this works. We're going to take a date formatter, and we're going to get a date helper. And because mocks and stubs work through dependency injection, what we're doing is we're taking our date helper and we're dependency injecting it into our call to the get formatted date on our date formatter object. So when we go to create our mock date helper, we're going to implement the stub provider, and we're going to have our handle method call. And this time, we're going to only look to see the method get today's date. And because it's the get today's date and we're here, I'm going to say hello Dreamforce instead of a date. And we're going to turn around and we're going to say, here's our date formatter test. And we're going to grab a mock instance of this object right here. And to do that, we're going to call test.createStub. And to do that, we're going to say datehelper.class. We're going to pass in datehelper.class, which is the class or the object we're stubbing, and the stub provider class we just created, that mock date helper, an instance of that. So that will give us this mock DH object, which is our mock date helper, and we'll call our object, system assert object, with our assert equals down here. We're going to say get formatted date with our mock object, and that will equal hello Dreamforce. So we've basically overridden the default implementation of get formatted date using that date helper with our mock object. Does that make sense to everybody? I swear this is the most complicated bit. This is also insanely powerful. Now, when would you want to use one of these? Here's the short and here's the nickel tour of when you want to use a stub. If the code you're testing uses an injected object, stub it. If you're testing code and the method you're testing passes an object into it, stub that object. Now, more specifically, if it relies on the behavior of a method on that passed-in object, stub it. If it relies on an object that is for data, like an account or something like that, not necessarily a actual logic class, but like a data object, data objects you can leave alone. They're sort of an exception. But if it relies on a logic class or a logic object, stub it. You get a lot of benefits from that. It's going to make your tests run faster. How much logic are you bypassing when you stub things? When you just hard code a return value? Yeah, a lot. And they're also going to bulletproof your tests so that when Team A changes something on the way the opportunity service works, your tests don't break because they changed the way their service runs. Now, you may still get warnings because the interface for that method has changed and the stub is now changed, but your tests will still pass. All right, here's the most controversial one. DML is evil. All right, so maybe not really evil, but it may also not be necessary. The slowest part of any application, regardless of whether it's Salesforce or a Rails project or whatever project it might be, is always data I/O. And this is pure physics. Moving bits around is slow. If you can avoid it, don't do it. Pretty simple, right? As of a few API revisions ago, you can start assigning an ID to an object in memory. And if you do not need to assert or to put that object into memory in order to assert that something has happened, don't do it. Here's how you do that. You can create an account, hi at Dreamforce. You can give it an ID. Now note, I'm giving it an 18-character string ID. You do have to give it a valid ID. It does not have to be a valid for that object type ID. Does that make sense? Right? So what you can do is use 0000001, 000002, so on and so forth. You can create yourself a test isTest class that is an ID service that provides you a statically incrementing ID. Drop those in there. Here's a contact. You can associate that contact with that account, and now you have a referentially intact account and contact pair. No DML necessary. And as long as you don't need to test a trigger or some other DML-associated process, like process builder or flow or an event bus related event, you don't need to actually drop that in there. How much time are you going to save? Dramatic amount of time. Okay? I don't think it's a secret that running tests on the Salesforce platform is a growth opportunity. One of the things that I think is probably a growth opportunity for us on tests is the speed at which we can retrieve and query data. And this makes it a lot faster. I have only anecdotal data, and I went to see if I could still log into the org to actually pull like concrete statistics, and my credentials have been turned off. But we noticed a substantial decrease in time, hours. Now that particular org takes about 2 days to run all of our unit tests for a deploy, and we noticed that it was taking hours less time. So your mileage will obviously vary. Hopefully yours doesn't take days to run all the unit tests, but you get the idea. So how do you determine whether or not this is really necessary? Are you testing anything that's DML related? Am I testing the logic associated with a service layer? If so, you probably do not need to do DML. If you have a service layer implementation and you're testing things in the service layer, you can probably pass in fully qualified objects with IDs and related objects without ever inserting them. Do you need to insert these records? And you may not know, but how do you know if you need to insert those records? Well, you can start using the Chaos Monkey approach. The Chaos Monkey approach is a Netflix thing they started doing a few years back. And what they do is they started just randomly breaking things in their tests and seeing what that did. What I suggest you do is to change your data factories or your data setups in such a way that you can easily flip a bit and see whether or not inserting is really necessary. So as you go to refactor a test, you can say, do insert false or true, and then say false, run your tests, do they break? Say true, do they pass? Okay, well then something in your test there requires DML. You can investigate that further, or you can just go, okay, I need DML on this one. But if it passes without you inserting it, well, good job. You got a question?
Yeah, going back several slides to the data from CSV, is there any way to load data from static resource CSV into memory?
No. I wish. Great question. His question was, is there a way to load data from CSV into memory rather than the database? No. I wish.
If the data is not inserted, will it show up via software?
No. No.
What's the best practice for getting CSV data or data in general into stubs?
What is the best practice for getting data into stubs?
When you show us the example stuff, there was names essentially hard coded.
Yes.
If you want to use the CSV, how would you put that into the stub?
So when you're using a stub, the point is to either calculate based on the input you're sending in on the method call, or hard code that data so that you're not. The point is to bypass all logic there in your stub.
Can you share your presentation on the?
I can make it available. I don't know how quickly. All I can do is send it to them, and I don't know how long it'll take it to be there. But I'm definitely going to send it to them. Yes. Thank you all for coming. This has been great. What a great way to end Dreamforce. We're the last session in here. So if you have questions, comments, Snyder marks, I have swag up here to give away. So come ask questions, comments, Snyder marks.